Mm. 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 Are we on air? Yes, good morning, Suprabhatham. Good morning, guys. Very good morning. Good morning. Good morning, everyone. Good morning. Good morning. Love to see you all. Very good morning, children. Good morning. Good morning. Very good morning to everyone. The AC temperature is 27. Do you think there is any need of 27? Good morning. Yes, beta. Today will be the last session of the gift program. So yesterday we ended actually. So today there was nothing like, but then I thought that when I came to know that this will be the last one, so I said I did not say goodbye to my children. So yes, I have so many things to teach to them. Not a problem. I will discuss something, but then today I will take a class. Means yesterday I said, tomorrow I'll be taking a class. Okay. Good morning, children. Good morning. Good morning. Okay. Okay. Do you know something about vitamins? Vitamin deficiencies, do you know? Are you aware about the importance of vitamins and minerals in our lives? The importance of diet, what we eat, what we become. Jaisa an, vaisa man. In North India, there is a saying. It's the local people, you know, the old people of the place, they say, Jaisa an means the food, Jaisa vaisa man, and so is the mind. What is our food that define our mind, that dictates our mind, and so how we think. Point is, here I'm not giving any lecture on any dietary habit. Point is, are you aware about that the importance of vitamins and deficiency of vitamins, what it can do? One point I just want to share with you, that scurvy is not the only deficiency of or deficiency sign of vitamin C deficiency. We know that vitamin C deficiency give rise to scurvy, isn't it? Right. But even without scurvy, people may be having deficiency or maybe partial deficiency of vitamin C. And vitamin C, along with another vitamin, these vitamins are, you know, their concentration cannot be in excess in our body. My question to you is, name the vitamins where excess in the body, you know, hypervitaminosis, the disease called hypervitaminosis. Name the vitamins which cannot be in excess in our body, irrespective of how much you take. They can be in deficiency, but they cannot in excess. Yes, please. Vitamin C is one of them. Vitamin C. Any other vitamin? Any other vitamin? Vitamin B12, very good. Cyanocobalamin, very good. Vitamin A, B, C. No, beta A nahi hai. Vitamin B and C. Please understand. Vitamin B, vitamin C. You can take in any amount. They will not get in excess in our body. My question to you is, why it is so? Why vitamin B and vitamin C, they cannot be in excess in our body? Hint. I've given you a hint when I said vitamin B and C, there is something common to both the vitamins. Yes, the first answer, Shanmukh. Shanmukh has given the correct answer, the first answer. In fact, many of you have the correct answer, but the first answer, Shanmukh, and he says that water soluble. Yes, it is water soluble. And now many people are saying water soluble, very good. So they are water soluble, they can be dissolved in water. And then what's due to that? What's due to that? How being water soluble, I'll help you out. If it is water soluble, you know, if it is in excess, it will be filtered out in the kidneys. It will be filtered out in the kidneys. Since it can move in the blood, it can be filtered out in the kidneys. And the kidneys can remove that excess in the form of urine. So literally, we can never have excess of vitamin B and vitamin C in our body. But hypervitaminosis A, hypervitaminosis D, these signs are there. However, vitamin D is always if you can get yourself checked. I think most of you are deficient in vitamin D. Do you know the reason why we are deficient in vitamin D? Most of us, and particularly those who are living in cities, metros, right? Those who are living in metros, staying inside the house. Staying inside the house, very good. Because staying inside the house, vitamin D synthesis requires ultraviolet radiations, and actually we protect our bodies. No doubt that excess of these radiations are harmful. They can tan our skin. They can cause many sunburns. Okay, solar energy, but at the same time they are also helpful in making vitamin D. Vitamin D is synthesized in the body from its precursor, and its precursor is a cholesterol. So cholesterol, it is synthesized from cholesterol. 125 dehydroxycholecalciferol. 1,25 dehydroxycholecalciferol. This is the precursor of vitamin D. So we have this, okay, but UV radiations are not there. Perfect. So vitamin D deficiency. Another vitamin which deficiency can be found in particularly those who are vegetarians, and that is vitamin dash. Which vitamin is found in which vitamin deficiency is found in the vegetarians? Vitamins better. Vitamin deficiency. And the correct answer is B12. And the correct answer is B12. B12 deficiency is found in the vegetarians. And the reason being B12 is found in the foods of animal origin. It is found in the foods of animal origin. Found in the foods of animal origin. Animal liver is the richest source. Richest source of vitamin B12. B12 is nothing but cyanocobalamin. B12 is nothing but cyanocobalamin. Animal liver is the richest source. So those who are eating animal liver, they can, yes, animal liver is also eaten. Those who are vegetarians, vegans, they might be thinking weird, but then beta, food is food, and for doctors, nothing should be weird. For doctors, nothing should be weird, because as a part of the training, we are not allowed to have any such feeling for anything. We have to touch anything, including the shit of a person, because yes, we'll be gloved, no doubt, we'll be masked, but then we cannot say that, oh my God, I cannot do that. No, for doctors, nothing is a taboo. Animal liver, yes, goat liver, people are eating, you're right, goat liver, people are eating chicken liver, okay? So goat liver is a very good source of vitamin B12. But yes, it is also found in some vitamins of, for example, some of it is found in nuts. It is found in spirulina. It is found in spirulina, which is an algae. What is this? Spirulina. Who is Lina? Spirulina. Who is Lina? Spiro and Lina. Spirulina. This is how you have to learn the names. So I am saying spirulina. It is an algae. which contains lot of nutrients along with vitamin B12, and it is not an animal. Okay, nuts. Second thing, in nuts we have vitamin B12. Otherwise, the foods of plant origin have very, very deficient, almost zero vitamin B12 can be seen. And deficiency of vitamin B12, deficiency of vitamin B12 leads to an anemia. Do you know that there is an anemia due to deficiency of vitamin B12? Who can tell me? Who can tell me which anemia? Some vitamin B12 foods are for vegetable that contains a very high amount. Spinach, beetroot, no, they are there, but it's not in high amount. Spinach is there, but in spinach, very, very low amount. Spinach contains, but it's not that it's a very high amount. Yes, you are right. And I don't know, I wonder why you guys not only know the name, you know the correct spelling also. I did not expect. Pernicious, it is pernicious anemia. Have you ever read this about vitamin B12 deficiency? Was that in your syllabus? Class 10 syllabus? Yes, in class 10 syllabus. Pernicious, P-E-R-N-I-C-I-O-U-S, pernicious anemia. Yes, but B12 is also synthesized by intestinal bacteria. Yes, you are right, B12 is also synthesized by intestinal bacteria. Okay, so it is also synthesized by intestinal bacteria. Deficiency signs, it's an anemia called pernicious anemia. Apart from that, it can also lead to mental problems. Okay, so mental problems also arise. Mental problems, okay, neuronal problems, okay, I should call them as neuronal, okay, nervous neuronal problems also arise due to deficiency of vitamin B12. It is rich in foods of animal origin. It is rich in foods of animal origin. Deficiency leads to pernicious anemia, a type of anemia where the cells are immature, RBCs are immature. In pernicious anemia, the RBCs are larger. The RBCs, rather than the normal sized RBCs, you know that RBCs are biconcave disc. Rather than this, RBCs are larger and they are also nucleated. RBCs are larger and nucleated, and they don't have hemoglobin. That's the problem in anemia due to deficiency of B12. So this transformation of the RBC precursor into this is done by vitamin B12. So if B12 is not there, rather than this type of RBC, you will have this type of RBC, and there will be lack of hemoglobin in the body, in the blood, and therefore the oxygen carrying capacity of the blood will be affected. Goat liver is a rich source. Nuts, spirulina. This is the only water-soluble vitamin which can be stored in the liver, right? It's the only water-soluble. I'm just writing these answers, MCQ answers I'm writing, learn them. Only water-soluble vitamin that is stored in liver, that can be stored in liver. Generally, water-soluble vitamins are not stored in the body, but vitamin B12 can be stored in the liver. Okay. Nerve problems, neuritis do occur due to deficiency, but then as your standard, please learn pernicious anemia. What else? It is the only cobalt containing vitamin. It's the only cobalt containing vitamin. It's a cobalt containing vitamin. The full name is cyanocobalamine. It is cyanocobalamine. This is about B12. In your diet, this B12 must be there, must be there. If not, then you can take B12 supplements also. There is no problem in taking B12 supplements also. The supplements of B12 come in the name of methylcobalamin, 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 methylcobalamin. Methylcobalamin, high dose methylcobalamin supplements can be taken. These supplements, particularly those who are vegans, or those who are vegetarians, okay? You know the difference between vegetarians and vegans. There is a big difference between vegetarians and vegans, but for both of them, they can take, if the diet is deficient. Eggs also contain, perfect, eggs also contain vitamin B12. Eggs also contain vitamin B12. Cyanocobalamin, dear children, never ever make this mistake. And what will be the first question? I have not seen anyone has written that so far. What is the first question that I'm expecting in this that has been asked in the last 3-4 NEET examinations? And just be honest, I'm going to write it, and be honest and tell me, did you know that? Did you know that this fact is there? And the fact is there that absorption requires an intrinsic factor, which is synthesized from the stomach. An intrinsic factor synthesized in the stomach, You know this. Be honest, how many of you know about this? Absorption of vitamin B12 requires. Yes, Kasil, Manasa, you are right, Kasil. No, not large intestine, but a small intestine, it is absorbed. Yes, you are right, Kasil, Medha, K Medha. Beta, where have you read about this? I told you this thing. Kasil's intrinsic factor, I told you. Absorbed in the small intestine. Acha, I told you about this. Yes, glycoprotein, Abu, very good, Abu. It's a glycoprotein. It is called Kasil's intrinsic factor. Okay, in my first week, I told, very good. Okay. But then it's good that you remembered it. It's good, very good, you remembered it, okay? So, okay. Did I tell you that different digestive juices have different pH? For example, the pH of saliva, the pH of stomach, the pH of the intestine, the pH of bile. That I didn't tell you. So in what context I told you about vitamin B12? Was I solving some question? Slightly acidic, sir, but saliva. Okay, no. In what context? The pH of stomach is less than 7. Quiz. Okay, I was playing a quiz. Okay, understood. Vitamin deficiency quiz. pH of saliva is more than 7. No. pH of saliva is slightly less than 7. Okay, so pH of saliva is slightly less than 7. How much it is? It is 6.8. Yes, you are right. I think one person has written. It is 6.8. But I don't mind anything in Googling, but then first you try to answer from your mind. And what happens that in the Google, the data is written as per the international standards. So sometimes they give a big range, but we have to learn from the NEET UG perspective. So, that's the reason I'll be giving you one datum. pH of saliva is slightly less than 7. It is 6.8, okay? pH of gastric. What is the meaning of gastric? Gastric means stomach. Gastric means of the stomach. gastric juice, pH of gastric juice, how much it is? How much pH of gastric juice? 1. 1 to very acidic, huh? Oh, it's very acidic, no doubt. 0.8 to 1 to 1.9. Very good, very good. Yeah, it is nearly 2. It is nearly 2. Okay, so it is, you can take it as 2, perfect. I do take 2, no problem. Okay, but as per the NCERT textbook, NCERT has written it as 1.8. NCERT has mentioned it 1.8. It is better to learn the same because in the examination, they will give you the same data. However, the range is from 1.5 to 2.5, 1.5 to 2.5. So I have taken the median value 2. I don't have any problem, but then learn 1.8 is the pH of gastric juice. Okay. Do you know what is bile? Do you know what is bile? Which organ produces bile? What is this largest gland in the body called? What is this largest gland in the body called? What is bile? Which organ makes bile? Answer is this organ makes bile, okay? It's the largest gland in the body, beta. It's the largest gland in the body, and this is known as liver. For digestion, liver synthesizes, okay? So liver is sending this to a sac-like structure. Liver is sending this juice to a sac-like structure. Which juice we are talking about? We are talking about bile. Liver is sending this to a sac-like structure called gallbladder. And then from the gallbladder by a common bile duct, by a common bile duct, it comes into the duodenum. It comes into the duodenum. By the common bile duct, it comes into the duodenum. It comes into the duodenum. You can see this. There is a small swelling here, and through that swelling, it is entering into the duodenum. Now, this C-shaped structure is duodenum. Remember that in mammals, the duodenum is C-shaped. It is duodenum. What is the length, or what is the meaning of duodenum? What is the meaning of duodenum? Have you ever heard about duodenum? Do you know the correct spelling of duodenum? Why it is called duodenum? Why it is called duoden? What is the meaning of duodenum? Duoden, spelling duodenum. It is the first part of small intestine. Very good answer, Vaishnavi. Akshaya, small intestine, very good. 2 ducts open into it. Only 1 duct opens. The other one is not clear, that Santorini duct. Well, first part of small intestine, very, very good. It passes food from stomach to the small intestine. It is a part of small intestine only. Very good. So first, starting from the stomach, perfect answer, perfect. Very good. Pancreatic duct. Yes, Divya, you are right. One is a pancreatic duct, perfect. And entrance of small intestine. Very good, very good. The first part of small intestine, it is better to say like that. Which 2 ducts open into it? You guys are saying now, maybe you have read about it. Which 2 duct opens into duodenum? It contains pancreas and liver. Very good. Liver and pancreatic duct. Very good. Very good. You are right. You are right. No problem. You are right. You know what happens when I say there is only single duct? Because the liver and the bile duct, they go by a common duct only. Which now what does it mean? Actually, the liver and the bile duct, they before entering only they shake hands. The liver and the bile, the pancreatic duct, the liver and pancreatic duct, they shake hands before entering. They say that boss, both have to go. Boss, both of us have the same work of helping in digestion, right? So why we are going separately? Let us join hand before that. So bile duct says, no problem, bro, I don't have any problem. So yes, then they join hands. They just merge, both the duct merge. And now, so this is white, this is yellow, this is a yellow and white. This common duct is the duct formed by both common bile duct and the pancreatic duct. This is pancreatic duct, pancreatic duct. So pancreatic duct and the common bile duct, both bile is coming from liver, it is coming from liver, and liver is called hepato. Therefore, this common duct can be called hepatopancreatic duct. The common duct can be called hepatopancreatic duct. Do you remember this name? Do you remember? Oh my God. Do you remember this? Okay. It is called hepatopancreatic duct. I'll write the legend here. Legend HPD, hepato pancreatic duct. Hepato, why? Because it is coming from liver. Why pancreatic? Because a part of it coming from the pancreas also. Both have joined together. Hepato and pancreas both have joined together, and now they enter into the duodenum. Okay, and beta, very, very, I require your concentration. When it is entering, there is a swelling. It enters through a swelling. When it is entering, it enters through a swelling. This color is not clearly visible, so we cannot use this color because so small, na? Though I try to make it bigger also, but let me use clear color so that this can be seen. I'll make it by this color. Okay, beta, there is a swelling here, and both these duct, the common duct enters into this swelling. This swelling, any natural swelling in the body is known as ampulla. And through this swelling, it enters into the duodenum. And on this swelling, God has given one sphincter. And I think everyone knows what is a sphincter. What is a sphincter? Okay, so I will first, I will put a label here. You have to tell me what is this sphincter called? What is sphincter? I'll write the name sphincter. Sphincter. It's a sphincter. Okay. And the duct is called hepatopancreatic duct. And I told you, any natural swelling in the body is known as ampulla. So this is known as HPA, ante hepatopancreatic ampulla. HPA, hepatopancreatic ampulla. Hepatopancreatic ampulla. Today you will be getting assignments. Maybe by late night I'll be giving you the assignments based on this. Hepatopancreatic duct, hepatopancreatic ampulla. But ampulla is any natural swelling in the body. Any natural swelling in the body is called ampulla. Over the ampulla, there is a sphincter. Now I want to see the result. Yes, Anu, what do you mean by sphincter? Come on. Samira, what is sphincter? Balaji, what is sphincter? Legend means just the full form of that. When I use the short form, it manages the input of food into yes, which constricts the amount, which controls the amount, very good. Ring-like structure, Manavi, very good. which controls, that manages secretion. Very good, all correct. Open to small intestine. Sphincter is present at the opening of urinary bladder also, which regulates opening and close. Yes, the perfect, I mean, most correct answer is which regulates opening and closing. All are correct. It controls the secretion, which doesn't allow smooth ring muscle. Yes, another correct thing that comes is it's a ring of smooth muscles. Okay, so sphincter. A sphincter is a ring of smooth muscles. A sphincter is a ring of smooth muscles. Okay, and what it does, what happens? Suppose I'll show this is a duct, and a part of the duct, which I'm saying that it has become dilated, and then it is now about to open, and it is opening into some wall, okay, like this. On here, I have seen that some muscle, a ring of smooth muscles has been seen. There is a ring of smooth muscles, okay? So smooth muscles ring has been seen. Okay, so you can imagine that it is all around. Well, the diagram is not very proper so that you can imagine it. I'll try to do it once again. I'll try to decrease the size, and now I'll try. Something, okay? So you understand that it is just, wound around it. This is wound around it on the back side, and it is, yeah, it's a ring. It's a ring. It's a ring of smooth muscles. It's a ring of smooth muscles, ring or a band. It's a band of circular muscles which are smooth. Smooth muscles means involuntary muscles, smooth muscles, and they are circular. Ring or band, just like a rubber band, ring or band of circular muscles. Now what will happen, beta, when this will contract, when the ring will contract, then you can imagine what can happen. Now suppose if the ring contracts, just imagine if this structure contracts, then what? Circular muscles have contracted, okay, and the size of the did you notice? However, it is not looking 3D. I do understand it's not looking 3D. Okay, it's not looking 3D, but then try to understand that the same thing has been now shrunk. It has been shrunk. And now, whatever was coming through it is now not coming, is now stopped. And whenever the muscles relax, again, this will open up and the substances keep on coming inside. Okay, but now the substance has just stopped here. It is not coming because the ring has the circular muscles has contracted. The muscles And these are the smooth muscle without any our voluntary control. It's a ring or a band of muscle. And what is actually this? This is a general definition of a sphincter. It is a general definition of a sphincter. I have drawn the diagram of the ampulla, but then every sphincter is like this. Like what? It is a band of circular smooth muscles, okay? And it can, yeah, there are certain places the skeletal muscles are also there, okay? So, you know, that is also, we can also control. For example, whenever we try to stop the urination, we can do that. Whenever we try to stop defecation, whenever we are in emergency, we can do that. And now those are also the sphincters. We can call them as urethral sphincters and anal sphincters. They are examples of the voluntary sphincters, okay? So urethral sphincters, external urethral sphincter, external urethral sphincter and external anal sphincters these are the two examples of voluntary. They are the examples of voluntary sphincters. God has given some extra control. God has given just extra control in urination. Otherwise, there is an internal also. The internal one is involuntary. Only the external one is given, one extra given, and that external one, that is just to avoid emergencies. Little children, they don't have control over them. Little babies, they don't have control over them, and that's the reason they cannot, I mean, they can pee anywhere, they can shit anywhere. I hope you understand the slang word which I'm using. Peeing is a slang word. The correct biological word is micturition, and I'm saying shitting. It's again a slang word. It is not a proper English word. The proper English word, a proper biological word is defecation. So, okay, I have used the slang word also, and I have used both the words I have used. These are the two examples of the sphincters which are voluntary in nature. Apart from that, all sphincters in the body, they are involuntary. That means they are made up of smooth muscles. Only these two are exceptions, we can say. And therefore, these two are not in the form of ring of smooth muscles. They are in a form of a different, they are in a different string. They are in a form of a different string. Generally, sphincters are ring or band of smooth muscles, circular muscles. And when the muscles contract, the opening is blocked. And when the muscles relax, the opening is open. Right now, the muscles are relaxed. Right now, the muscles are relaxed. Relaxed muscles, okay? That means we can say sphincter open. Sphincter open, okay? Muscles contract. I can say here, sphincter closed. Are you guys with me? Are you guys with me? Have you understood the sphincter? A sphincter is not valve. A valve is a different situation. A sphincter is not valve. Please understand. Okay. I hope you understood this. Now, a sphincter you have done now. A sphincter is not a valve. There is a difference between valve and sphincter. Okay. So a sphincter, I'm writing when you are excited. A sphincter and a valve. The sphincter you have seen, it is just a gateway maintaining or regulating opening and closing. So it's just regulating, the opening and closing. It's just regulating that. Whether gate open, gate closed, gate open, gate closed. That's it. It's just regulating that. Hello.
Anurag ji,
Sir.
in class is missing yesterday.
Sir, I am coming from here. I am right now in the gift, taking the gift class. I am coming from here, sir.
Okay, sir. Okay.
Yeah, I am coming here, sir. Okay. Now, what is a valve doing? A valve maintains unidirectional flow. A valve regulates unidirectional flow. In fact, I should write it maintains unidirectional flow. A valve maintains unidirectional flow. That means a valve, it prevents backflow. It prevents backflow. It prevents backflow. For example, like if this tube I have shown in a tube having valve and the direction of the flow is this only, so we can say that how a valve will be like. A valve will be like this. It will be like a flap. It will be like a flap. You can see this. Which means that if a flow is coming from this side, it can move. But the moment it tries to go back, they will shut. Okay, which means that if the flow is coming from one side, now suppose if the flow is going from in this side, suppose, okay, suppose if the flow is trying to go this side, you will find that these structures have now closed very strongly. They have closed. These structures have closed very strongly. When you push them a little bit, they will close, just like, our doors. Many of our doors are designed in such a way that they can close only, they can open in one direction. And if you try to open on the backward direction, they will get closed. And if you try to push more, they will make a noise. They will make a third sound. Okay, so if any flow is trying to go back, it will close the valve. So valve open in the first picture, valve open in the second picture, valve closed. Whereas in this case, you will find that it is just okay. So in this case, how a sphincter would be like? A sphincter is a ring of circular muscle. And here you can see that this muscle has contracted. The circular muscle has contracted. And because the muscle has contracted, this opening has been narrowed. And because of the narrowing, now neither this way nor that way. It is just a gateway. If you want to go this way or that way, any way you can go. Right? Any way you can go in this one. Okay. Only thing is now you cannot go. Now you can go. Now you can go. Now you cannot go. That's it. Here, only you can go like this. If you want to go like this, they will close in the heart because of the pressure difference. The blood tries to return back. And you know what happens? These valves, they make a noise. They make a noise whenever, because of pressure, because the pressure keeps on changing in the heart, and the pressure makes the blood move back to the heart, from the arteries back to the heart. These valves close with a noise, and we get tup sound, tup. Again, when due to pressure, the blood from the ventricle tries to go back into the atria. Atrioventricular valve close, and we get lump sound. Atrioventricular valve, lump, and semilunar valve, dup, lump, dup, lump, dup. Okay, so when it tries to go back, it will close. If you try to push more, it will be closed more. It become more tight. And if something is coming by a force, it will make a noise, just like you have doors. Even in this studio door, I can only open from outside to inside. If I try to go from this way, just to push it, it cannot go. Hi, if I break it, then it's a different I break it, then it is a different thing. But you cannot even break. There is an arrangement that these heart valve don't get broken. You know that in our heart there is an arrangement. Anyone who know about this? Anyone who has ever heard about chordae tendineae? Anyone who has ever heard about something, some collagenous threads are there which prevent that they cannot go back, they cannot they cannot be broken. Anyone who is aware about this, sir, what happens when both sides valve open? That is a disease. That is a disease called prolapse of valve. If you break them, they will open up that way, and that is known as the prolapse of valve. Prolapse. Valvular prolapse. It is a disease. Say, anything can. God has designed the body in order to perform, in a normal way, and all the arrangements are being done. We have given immunity so that the system fight with the disease. Our same immunity fight with cancers, and we are this is happening in the body, but that does not mean that we don't get cancer. We do get cancer. That does not mean that we don't get disease. We do get disease. In the same way, God has given this arrangement that there will be a unidirectional flow, but that does not mean that they will not be broken. Yes, even they can be broken. So disease can happen, accidents can happen, even this can be broken. What I was telling you, suppose if I make this diagram, and I'll show you. Blood can come from here. Blood can come from here. But where the pressure is more, of course, in the ventricles. Such thick walls, thicker the wall, more is the pressure. You know this. The simple Starling's law. Thicker the wall, more is the pressure. It's all muscle. More power. And more power, more pressure of the blood. Thicker the wall, higher will be the pressure. So obviously the pressure in the ventricles is higher. My question to you is, any idea what prevents the valve to become broken? Because in terms of the pressure, they can get broken. I have drawn them so thick, but in reality, they are not even these thick. They are very thin. I have drawn them a little thicker, but in reality, they are not even this. This one. Yeah, good. Okay. This is a interventricular septum. The disadvantage of this online classes is that children don't draw anything. They think that everything will get, after all, in the form of PDF. And no problem with that. I don't have any problem with that. The thing is, they don't develop, this, because in the medical college, I don't think so. You'll get the PDF of the real class teacher notes. You can get the PDF, you can get the, the photostat of someone who has written those notes in the class. But the real teacher's note will be the best when you write by yourself, okay? So, done. But pressure is very high here. A high pressure. Pressure is very high. Pressure is very high as compared to the pressure in the atria. And because of this high pressure, there is always a chance that these valves will be pushed to the other side. If they push to the other side, you can understand that this can happen. You can understand if they are pushed to the other side, this can happen. This can happen. And this is known as prolapse of the valve. Prolapse. And the problem with that is leaking occurs. There is a leakage occurs. They can, just like a door, if I push it too hard, the door will be broken. And now it can open on both the sides. In fact, it is not real opening, it is actually broken. So anytime it can also fall on the head also, okay? So because of the high pressure, there is a risk. Done. What God has done, God has made an arrangement here. And the arrangement is some threads are tied, some collagenous, and you know that collagen is very, very strong. Strongest, most highest tensile strength in the body, highest tensile strength is of collagen. Collagen fibers, they have the highest tensile strength. Collagen fibers are made up of protein. They are made up of protein called collagen. They are also called the white fibers because they look white in color. They are also called the white fibers because they look white in color. Tell me how many cusps are there on the right hand side? How many cusps are there on the right hand side? But I cannot show all those. So there must be one on that side. Okay. So I am now making the arrangement for all the three cusps. These bowl-like structures, bowl, patra. These bowl-like structures are known as cusp. C-U-S-P, cusp. These bowl-like structures, they are called cusp. They are the one that makes the valve. They are the one that makes the valve. God has done an arrangement. God has tied threads on it, and the lower end of the thread is attached to some outgrowths on the inner side of the muscle of the ventricle. So there are some outgrowths, some small papillae that come out. Some small papillae that comes out, like one of them is this papilla. You can see papilla means some small outgrowth. Some small outgrowth, one of them is this papilla, one is this papilla, one is this papilla. So these are the papilla, and they are muscles actually. Okay, I can call them papillary muscles. I can easily call them papillary muscles, okay? So they are papillary muscles. Papillary muscles. These are also papillary muscles. So 2 papillary muscles are there on the left-hand side and 3 papillary muscles are there on the right-hand side. 3 papillary muscles are there. These are the cardiac muscles only. So muscle, and it's a small outgrowth. So that on the tip of it, these collagen fibers can be attached, and the other end of the collagen fibers are attached to the lower side of the cusp. These are the cusp of the heart valve. Where is the mitral, right or left? Mitral valve. Mitral valve is right or left? Come on. Where is the mitral valve? Yes, mitral, in the beginning, I was so average that time. I got confused that mitral is right or left, okay? So, near our house, all those, because our parents are engineers, so, all the HMT colony was there, and all their children, almost they were married at the same time, some senior, some little junior, like that. So we have got annas and akkas all around of us, okay? Yes, we used to call them annas and akkas. We were playing since childhood, and we are calling them annas and akkas, okay? So, then we used to discuss these things only. And one of them, they were using this trick that like L for left, mitral has L, like that. A for dark, dark band, A band, I for light, light band, I band, like that, this type of relation. I also started using that, and this really helped me. So any trick, learn at some time and that gone into your DNA. I mean, DNA means that gone into your deep, so that you are now making it and you are utilizing it even after, let us say, around 30 years. 30 years later also, you are using that. Papillary muscles, there are 2 papillary muscles on the left-hand side and 3 papillary muscles on the right ventricle. The cusp of the atrioventricular valve. This is a tricuspid valve. Tricuspid. Both are AV valve. It is a tricuspid valve. The upper side, you see those 2 bubbles, those are the atria. Ventricle, they have got thicker valves. As you can see, the left ventricle has the thickest valve. The left ventricle thickest layer of muscles. Thickest layer of muscles. So more the muscles, more will be the power. And therefore the power generated in the left-hand side is higher than the power generated on the right-hand side. The power generated on the left-hand side is higher. The pressure generated on the left-hand side is therefore higher than the pressure generated on the right ventricle. And no doubt about that, you can easily understand that the pressure in the atria is lesser as compared to the pressure in the ventricles. I'm talking about the pressure generated by its contraction. Otherwise, there are times if the ventricles dilate, they become relaxed. Okay, so what happens that their pressure goes down. But in general, when they contract, because the problem of valve breaking of the valve occurs when there is a contraction in the ventricle. You understand? Why? when the problem of breaking occurs. Problem of breaking occurs during ventricular systole. So these collagenous threads, they are preventing them. Anyone who knows the name of these collagenous threads? Anyone who can tell me what these collagenous threads known as? Anyone? Okay, you must have just. Yes, cordi tendini. Very, very good. They are called cordi tendini. Very good. These are called cordi. Corda one, cordi many. There are many in number. Cordi tendini. Tendini. Cordi tendini. Cordi tendini. Why I am calling it tendini? Just like tendons, which are rich in collagen muscle fibers, collagen fibers. In the same way, this is also rich in collagen fibers. Just like tendons are rich in collagen fibers. Dear children, this prevents the valve from getting prolapsed. I was remembering one question here. But before that, let me tell you what happens if these break. Suppose if they break, then there is a leakage of blood occurs. Blood start leaking into the atrium when the break in these mitral valve or tricuspid valve occurs. Then due to contraction, the pressure is very high. At that time, the valve are not tightly closed. They remain a little opened up. And therefore, from there, blood start leaking back. Blood start leaking back. Hope you understand this much. Do you know that how much of the blood is pumped by the heart in 1 minute? Do you know how much blood is pumped by human heart in 1 minute? How much blood is pumped by human heart in 1 minute? 72 ml. By the heart in 1 minute. 140 ml. Yes, 5 liters, approx 5 liters. Approximately 5 liters of the blood is pumped by the heart in 1 minute, and that is called the cardiac output. So many things to discuss, guys. I had a very nice time with you guys. Only problem with some of the children who are just coming here as leisure here. They are just coming here as they are seeing any YouTube videos. So after certain, like what's the problem in the YouTube video is that they are deliberately made smaller, not the classes. Classes are 1.5 hour classes. I'm telling you, other YouTube videos, 10 minutes. Our attention span is decreasing because of those, YouTube shorts and reels and tic-tac, all those things. They know that up to 15 seconds, we can even concentrate on the shit. So do not continue beyond 15 seconds. So they are now, and children these days are actually exposed to these things in an early age. Suppose if I am seeing them now, so I have lived a life when my attention span was required the utmost, then I had. But now because of this, tic-tac, something like tic-tac and this reel and shorts, YouTube shorts, attention span is decreasing. We want, after some time, it is difficult for us to continue further. I know, but that is for entertainment. And remember that nothing in life can be achieved in comfort zone. Believe me, I am a living example of that. Nothing in life can be achieved in comfort zone. I repeat, nothing in life, always remember, no pain, no gain. No pain, more pain, more gain. If your life is giving you more pain, that means life has already done arrangement for you for the better gains, bigger gains later. Always remember, no pain, no gain. No pain, no gain. More pain to more gain. This is a rule. This is something. This is a law of nature. You have to give only, then you can get. Just like a banking, you have to invest money in the bank, and then only one day you can withdraw the money. The bank doesn't allow you to withdraw over limit. We want to withdraw at the time of examinations, at the time of tough competitions. I'm not saying examinations, your IP examinations are very easy. The people like you have got that much of intellect. Even for 1 month study, you can make wonders there. I'm challenging. You can make wonders there. But NEET is something different. It is not an examination, it is a competition. So it is not that it is easy, you can do. It's not the question of easy and difficult. In competition, a paper is easy, a paper is difficult, is not at all matters. You understand this? I repeat, in a competition, a paper is easy or a paper is difficult. It doesn't matter at all. In IP examination, it matters. If the paper is easy, score is high. The paper is difficult, score is low. In competition, just let me tell you, if suppose from this state, they have to take 1,200 doctors, suppose. 1,200, they have to give the seats of their choices, 1,200 in 1 year. This year, paper has come very easy. Very easy. How many doctors will be selected? Come on. The limit is 1,200. Paper is very easy. How many doctors will be selected? 1,200. And next year, paper came very tough, very difficult. Difficult calculations, many questions, no one could understand what they are asking. How many they will be selecting? Again, 1,200. You understand? It doesn't matter, paper is easy, paper is difficult. We are on a path where, and day by day, things are getting difficult and difficult. In what way they are getting difficult? Now, when I wrote the examination in the year 1995 in Rajasthan PMT, 25,000 students wrote the examination. I can say that in 25,000 students, around 5,000 to 7,000 have just written, they have not done the preparation. Out of them, I can just remove 5,000 more who have not done the preparation with that intensity. So really, the competition is, I think, among the 12,000 or 15,000 guys. Today, it is among how many? No, 16 lakhs is all India. I'm just saying in AP state. How many people are writing in AP state and how many are getting category A seat? Let's take the ratio. And no, that time it is not that the seats were 10,000. No, 217 seats were of category A. I mean, we did not have category A, B, C. We had uncat, I mean like GCAT. GCAT means general category. GCAT and the remaining seats, total seats to be filled 500. Total seats 500. 217 were GCAT and remaining are for reserved and some are for other reserved categories, government officials, some are from there are many other chancellor seats and all, you understand. So no doubt, when we say that hardly 12,000 children were competing, but today even there, if colleges have become more, no doubt, but the population has grown in geometric progression. Colleges can only grow in arithmetic progression. And population grows in geometric progression. J-shaped curve, exponential. You will learn about that in mathematics. Things are getting ruthless, and therefore, I don't want that everyone should go, and I'm also very sure not everyone can go to medical college. Also, I'm sure whoever is coming to us, we have thousands of children in every section, in every classes. We know that, but I'll be happy, your parents will be happy, and in the future, you will be happy if you can say, sir, I did my best. This is my upper limit. And those who have done that, And by chance we see, oh my God, that was such a hardworking person and he did not get a college of his choice. We have seen that in life, they have done wonders in other fields. Medicine is not the only field where we can be successful. They have done wonders in other fields, sometimes even more wonders. But please, I have given my best. Your parents will be happy, I will be happy, and moreover, you will be contented. You will not have grudges in life. God bless you, kids. God bless you. Love you all. A nice time with you guys. Okay. However, we'll be in chatting for a few more days. Okay. But then your other class is about to come, and I am now taking goodbye. I'm saying goodbye. God bless you. Malthus theory, Chinna. Oh, very good. यार ये सब बच्चे क्या है Malthus theory जानते हैं. मैंने कहा population grows in. Oh my God. Love you, beta. Love you. At this age, you know Malthusian theory. God bless you. Bye-bye. Bye-bye. QR code. चलो ले QR code. ये 10th के बच्चे हैं, इनको माल्थस की थ्योरी पता है. Hope I was able to make you understand the things. If something is not, sorry for that. I tried my best. In fact, all of us tried our best to give you the best. If something is not, then it is regret. God bless you. You'll do very good in life. Bye-bye. Take care. Bye-bye. Exam hoga. Yes, there will be exam.